So in this video, we will talk about cycloalkanes and bicycloalkanes. Now, cycloalkanes have a formula of CnH2n, where the n is a number of carbons, okay? And having this here, it's more like an alkane. This here, it's more like an alkane, but it's actually in a ring form. This is a carbon atom, carbon atom, carbon atom right here. So this 1, 2, 3 carbon atoms. So if it's the normal alkane, we will actually call it propane. So in its name, cycloalkane. So cyclo and alkane. So the alkane name is propane. So in naming it, we will call it cyclopropane for this particular one. So this actually a cyclopropane. And this right here, 1, 2, 3, 4 carbon atoms, which would be cyclobutane. This right here is cyclopentane, and it goes on that way. Now let's take a look at it with certain substituents. Now with the substituents like bromine, we know that in naming bromine as a substituent, we go by the name bromo instead of bromine. So this right here, we don't have to give the number. This is actually this right here is bromo. Now how many carbon atoms? 1, 2, 3, 4, 5, 6. So we have bromo, cyclohexane for this particular first one. Now with the second one, we have 2 bromines. So in naming it, we have 1, 2, that is in counting it. So 1, 2, 3, 4, 5. So we count in this direction, not in this direction. So 1, 2 dibromo. Dibromo. Cyclohexane. Right here. Very simple as that. With this as well, we remember this to be an isopropyl. So an isopropyl on top of a cyclopropane. So in naming it, we will call this one isopropyl cyclopropane right here. That is the common name. And with this as well, this is a butane with a methyl group. So we call it methyl cyclobutane, right? Yeah, butane, right? And this here we know as a tet-butyl in our former video. We know this is a tet-butyl, this particular substituent, and it's on top of a cyclopentane. 1, 2, 3, 4, 5 carbon atoms. So this is a tet-butyl cyclo pentane, right? Yeah. And this right here, we have a metal as a substituent and an ethyl as a substituent. Now in naming it, the ethyl will take the preference to be first. So we start naming from here. 1, 2, 3, 4, 5. Okay, so this is so the parent chain is actually propane. Now in naming it, we have 1 ethyl, okay, 1 ethyl, 3 methyl, pentane right here. So this is the name of this particular one as well. Now we want to talk about bicyclic compounds. What are bicyclic compounds? Now bicyclic compounds are alkanes containing 2 fused or bridged rings. So in an alkane where there are 2 fused or bridged rings, they are known as bicyclic compounds. Let's take examples to understand them more. Now with this particular compound, the total number of carbons here, 1, 2, 3, 4, 5, 6, 7. Okay, now this is a bicyclic compound. In a bicyclic compound, we have something known as the bridgehead. Now these are the bridgeheads separating these particular, so it's like this particular one and this particular one conjoining, like they are coming together. Okay, so we will have 3 different sides. We have the left side of the carbons, we have the left side, we have the right side, and we have the middle side that is on top of the bridgehead. Okay, so we will go into the nomenclature of this. Okay, so taking a close look at here, the total number of carbons 1, 2, 3, 4, 5, 6, 7. Okay, so this is actually in an alkane, you're naming it as an alkane. So this is actually heptane. You say this is a heptane, but this is a bicycloheptane to be precise. Now, what is the IUPAC naming of this particular one? Now, we will actually count the number of carbons on the left side, the number of carbons on the right side, and the number of carbons in the middle. So the number of carbons on the left side, there are 1, 2, apart from the bridging ones, 1, 2. So we have 2, and in the middle we have 1, and on the right side we have 2 also. Now we will name it so that the highest numbers actually come forward. So with this particular one, we have 2, 2, and then 1. So in naming this particular compound, okay, take note of these ones. In naming this particular compound, this will actually be called bicyclo, then you bring a square bracket, 2, 2, 1 heptane. Now this is the name of this particular compound, bicyclo-2,2,1 heptane. Simple, right? Let's take the next example so we will get at the more. Okay, now with this, these are the bridging atoms, so this is actually fusing these two. Now on the left side, okay, on the left side we have 1, 2, 3 carbon atoms. We have 3. In the middle there is none, so we have 0. On the right we have 1, 2, 3, 4. We have 4 carbon atoms right here on the right side. Now the total number of carbons here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually a nonane. Okay, a nonane, specifically a bicyclononane. Now in naming this, the numbers, the bigger number will actually come first before the smaller number. So this is actually bicyclo 4 with a square bracket 4, 3, 0. Okay, nonane. And is the name of this beautiful compound right here. Simple, right? Let's take the last example so to clarify every single thing. Now these are the bridging atoms of this particular bridging atoms here. You see something strange here. We have an isopropyl. It is all going to come in, so they all come in the naming. So we have isopropyl right here, but the total number of carbons should also be counted. So 1, 2, 3, 4, 5, 6, 7, 8. So this is a bicyclooctane, right? Now let's count the number of carbons on each side. Now on the left side we have 1, 2. These are the bridging ones. On the left side we have 1, 2. So we have 2. Now in the middle we have 1, 2 right here also. So we have 2 as well. On the right side also we have 2 right here. So the name of this particular compound will be isopropyl bicyclo square bracket 2, 2, 2 octane. This is the name of this particular bicyclic compound.